Welcome to the second video of the entire chapter of permutation and combination where I teach you the entire H2 math chapter from scratch, right? And before we actually go into the specific formulas, it's very important that we first know the two basic counting principles. And what are these two basic counting principles? They are your addition principle and your multiplication principle. Okay, so multiplication principle. Now, these two principles are the fundamentals of it all, which means that before we even use the formulas to go and calculate things, we must first know what is the addition principle as well as the multiplication principle first, right? Because they will appear in all questions, regardless if it's a permutation question or a combination question. So let's look at the addition principle first. So the addition principle actually is a very fanciful way of saying how many different ways can two events happen if two events are mutually exclusive. Okay, so let me just paint a picture over here for you. Okay, so let's say I got two events. Okay, and let's say the two different events, maybe let's say I have like a transport, right? Okay, let's just put it transport this way. So let's say I have two events here, right? And then this is my universal set over here. So let's say I can either take a train or a car, right? And the thing is that the event of taking a train or a car the events are mutually exclusive. Now, why are they mutually exclusive? Mutually exclusive means that they cannot happen at the same time. It just basically means that. So mutually exclusive means they cannot happen at the same time. And of course, if you think about it in the common sense, you can't take a train and a car at the same time, right? So cannot happen at the same time. So since they cannot happen at the same time, you can see that in the Venn diagram over here, right, the two different events, there is no overlap, right? There's no overlap between the two events. So suppose that I have 5 different trains that I can take. So I have 5 trains. So T1, T2, T3, T4, T5. And then let's say for the car, I have 4 different cars. So C1, C2, C3, C4. So given that they are mutually exclusive, how many different, or what are the different ways, or not say different ways, but how many different, what's the total number? Yeah, that's the question. So the question is, what's the total number of ways to travel? Right? How many different ways can I travel? So you can either take a train or a car. Right? You can't take both at the same time, but you can take one of them. And under the train over here, I have 5 different options. And for car over here, I have 4 different options. So I can either take a train, which has 5 different options, or I can take a car with 4 different options. And this is where statistics become a lot easier when you realize this one thing. Whenever you use the word or in statistics, or basically means plus in stats, right? Because you can take 5 trains, so you have 5 options already, or 4 cars. So you can have 5 options or 4 options, which means in total, you have 9 different options, right? So this is the addition principle. So you see the plus sign over here, it basically stems from the word or. So you can think of it as the addition principle comes from the word or. Okay, so whenever you see a word or, as long as it's mutually exclusive. Okay, so I just need to put a very important caveat over here, right? They must be mutually exclusive. Must be mutually exclusive, right? In order for you to apply this. But don't worry too much about it because there's a lot of instances where you realize that two events are mutually exclusive in the question and you will figure it out. Okay, but this is the basic addition principle concept. Okay, now let's say I got the other concept, which is the multiplication concept over here. So the multiplication principle, right? And similar to the addition principle, the multiplication principle also has its own keyword. Okay, and this keyword over here is basically your n. Okay, this is your n keyword. And note that for multiplication principle, this one is usually applied in the context of independent events. Okay, so what are independent events? Let's just define that first, which are very different from mutually exclusive. So let's just do a recap, right? Mutually exclusive means cannot happen at the same time. Okay, that is the definition. But for independent events, the definition of an independent event or independent events means that they can happen at the same time. Okay, they can happen at the same time. But the occurrence of one event, so if one event happens, right, it does not affect the other. Okay, so you can think of it as two different events that they can happen at the same time, right? Or they can happen in sequence, right? Yeah, there's an overlap. But the occurrence of one, it totally does not affect the other one. Okay, so if I were to draw the Venn diagram over here, right, let's just use this as an example. Okay, I'm just going to have to zoom inside here, right? Okay, perfect. So let's say I got two different events. There's an overlap between these two. And what is a possible example for this? Or rather, let me just use this. Let's just use a real life scenario as an example. Okay, let's say I got 5 different alphabets. Okay, let's say I have 5 different alphabets. Now, what are my 5 different alphabets? A, B, C, D, E, right? Relatively straightforward. So let's say I want to set up a password on my phone. Okay, so let's say password on my phone. And my password on my phone has 4 different digits, right? So it's a 4-digit password. Now, based off these 5 different alphabets, how many different passwords can I create on my phone in total, right? So you realize that these 5 different alphabets, right? Let's say the first digit, let's just zoom into the first digit over here. How many different digits can fit into this digit over here? Or rather, how many different alphabets can fit into this first digit over here? You realize that over here, I have 5 different digits that could be in here, right? Because over here, it can be A, B, C, D, or E. Now, for the second digit, how many different options do I have? Once again, I have 5 again, right? Because let's say in the first one, in the first slot, let's say I choose A, right? Assuming I choose A in the first one. Now, in the second one, given that I have chosen A in the first one, does that mean in the second one I cannot choose A? The answer is no, right? And you yourself, having your own phone password, you also know, right? If you put, let's say, 1 in the first digit, doesn't mean that the second one you cannot put a 1, right? And you realize that for each slot over here, you have 5 different options each, right? Because you can put A, right? You can put all A, right? Or you can put A, B, C, D, right? So there's 5 different options for each slot. So in total, right, how many different passwords can you create? So the total number of passwords would just be, I got 5 options for the first one, followed by 5 options for the second one, followed by 5 options for the third one, and the last but not least, 5 options for the last one. And therefore, the answer over here is 625 different passwords, because the event that you chose an alphabet in the first one, it totally does not affect which alphabet you choose in the second one, right? They are independent events in that sense, right? And this is basically the 2 different core principles that you need to understand first before we actually go into the formulas, and then it's your addition principle and your multiplication principle. So before we actually move on, let's just practice some questions over here. I have a total of 4 different questions that we're going to try together before we actually jump into the next concept, right? So this is a checkpoint for you to make sure that you really understand the concept before you actually move on, because as you know, math is progressive, right? There's no point jumping if you don't understand your basics. So let's look at this question. Feel free to pause this video first, right, to attempt the questions, because I'm just going to jump right into it. Okay, so you pause this video now if you need. If not, let's jump right into this question. So a person can travel from town A to B, right, by road, air, and sea. So when I look at this question over here, I realize that, if you travel by road, that means you cannot travel by air. If you travel by air, it means you cannot travel by sea or road, right? So you realize that these three different options, right, the three different options, what are they, right? They are all mutually exclusive, right? Because you can't be doing both at the same time. So if I were to draw out a sort of like a diagram, right, from town A to town B. Now from town A to town B, I can either go by road, or you realize the word I'm using the word or, right? Road, air, or let's say sea. So road, there is three different options. Air, there is two different options. And sea, there is just one different option. So the question is, what is the total number of ways that I can travel from A to B by road, air, or sea? So since all of them are mutually exclusive, which means that they cannot happen at the same time, that means my total number of ways would just be my road, or, so it's air, or sea, right? So I'll just add all the different ways that I have together. So which means that in total, I have 3 plus 2 plus 1. That means I have 6 different ways that I could choose one from, right? I could choose one way out of these 6 different ways to travel. And that's why this is the basic addition principle in play. Okay, so that's the end of question 1 over here. Okay, so hopefully you got this, right? Now, next. Okay, feel free to pause this video to tackle the question. I know that I have left the answer at the bottom right hand corner, but just feel free to tackle the question and make sure that you're able to get the right answer, right? If not, do watch this video over here. Okay, so I'm going to go through this video. Make sure you pause it right now if you need. Now, the next question is, find the number of squares contained in the 3 by 3 array, where each cell is a square. So how do we actually tackle this question over here? So you realize that as long as we have, or rather, let's just start off by defining what is a square, right? A square is a 4-sided figure whereby each side is the same length. So as long as this side and this side and this side and this side, they all have the same length, then that would mean that we have, in total, a square, right? It doesn't matter how many units are on each side, as long as all the sides have the same number of units. So to tackle these type of questions, right, maybe if we want to draw our table first to actually go and organize our thoughts, right? So given the constraint of the question is a 3 by 3 array. So what that means is that how many, or rather what are the different possible kinds of squares that we can get, right? So I'm just going to write here the type of square and the number of such squares. So since it's a 3 by 3 array, I could possibly get a 1 by 1 square, right? Definitely possible. I could also get a 2 by 2 square, right? I also could get a 3 by 3 square. Could I get a 4 by 4 square? The answer is no, right? I can't get a 4 by 4 square because that would be outside of the current constraint. So in such a chapter like this, right, it's very important to exercise some common sense, right? And I know it's common sense is really just common sense, but sometimes in exam people just tend to blank out and then they forget this stuff basically. So stay calm, right? You can't get a 4 by 4 square from a 3 by 3 array. So how many 1 by 1 squares are there? You realize that in total you have 9 different 1 by 1 squares, right? How about 2 by 2 squares? So let's count. This is 1, this is 2, this is 3, this is 4, right? So far you have 4 different 2 by 2 squares. So you have 4. And last but not least, 3 by 3 will be the whole thing over here. So this is 1. Now, what is the total number of different squares, right? you realize that these three things over here, they are all mutually exclusive, right? If you're a 1 by 1 square, you cannot be a 2 by 2 square. Likewise, if you're a 2 by 2 square, you cannot be a 3 by 3 square. So they are all, in other words, you're mutually exclusive, because you can only be one type of square. So therefore, the total number of different squares will just be 9 plus 4 plus 1, which therefore gives you 14 different squares. Okay, so yeah, that is how we actually tackle this. And sometimes, you know, the working might not be so much of formulas, but really it's just how you see the question, right? So my best advice to you is for this chapter, right? Just make sure you exercise common sense, and that's about it. All right, so yeah, that is question 2 over here. Now question 3. How many different ways can two pupils, or there are two pupils of different gender, be selected from a group of 4 boys and 3 girls? So that this is where it gets a little bit more interesting, right? So before we do this, make sure to pause this video over here to attempt the question. If not, let's just jump right into this over here. So assuming I have a group, okay, so this is my group. Now I have 4 boys, 3 girls. So I'm just going to write it out, right? Boy 1, boy 2, boy 3, boy 4, girl 1, girl 2, girl 3. And the constraint of the question is that they are of different genders. And I have 2 pupils. So I have 2 slots. Just imagine 2 slots. Now, given that the constraint of the question is that they must be different genders, right? That means we know that it has to be either boy or girl, right? They both have to be different genders. Now, another thing to note is that in this question, they say how many different ways can 2 pupils be selected from a group, right? In this question over here, the order does not matter, right? So over here, the order does not matter. And why does the order not matter? It's because we want 1 boy, 1 girl, right? At the end of the day, if we choose boy or girl first, it's going to be the same thing as if we choose girl first then boy. It doesn't matter whether we choose boy first then girl or girl then boy, we will end up with the same thing over here, right? We'll still get 1 boy and 1 girl, right? We can just see them very, very clearly like that. So that means for the boys, right, how many different boys can we choose from to fit that 1 boy slot? That means over here, I have 4 different boys that I just need to choose 1 from. And then for the girls over here, there is just 3 different girls that I could choose from, right? So therefore, how many different ways or how many different combinations of boy-girl pairs can be formed? So therefore, the total combination would be 4, choose the 4 boys first, and then the 3 girls. And therefore, the final answer over here is 12 different ways. Or you can think of it as 12 different combinations over here. So notice how over here, right, we multiply them together, because the question is asking boys and girls, not boy or girl, right? So over here is boys and girls. And whenever you see the word and means multiply over here, very, very straightforward. Okay, so this is multiplication principle at play. Okay, without further ado, let's just jump right into this question. So make sure you pause it beforehand to actually tackle this. So I have 5 different characters. 1, 2, 3, 4, 5. Now this one is your alphabets. So this is your uppercase, uppercase. This is digit, digit, digit. And the constraint of the question is that it's made up of 2 different letters of the alphabet, right? So I know that these 2 over here are different. But then these 3 over here can be the same or different. So let's start off with the first digit over here, right? In the first digit over here, how many different possible digits can I fit into the first one? There are 26 different digits in the English dictionary, right? But remember, the constraint of the question is that the second one cannot be the same as the first one. So after I've chosen the first alphabet, how many options are there left in the second? And in the second, that means over here, I will have 25 different alphabets. Because it doesn't matter what I choose in the first one, right? Once I've chosen the first alphabet, and then when I move on to the next one, I will have one option less, right? It doesn't matter what it is. But overall, I will have one option less because I've already chosen one, right? So that's why we minus one for the second. Now for the last three, they may or may not be the same. So since they may or may not be the same, means that, they can be the same, right? So in the first digit, I got 10 different options because 0 to 9, if you count your fingers, you've got 10 different options. Then for the third and fourth digit, the fourth and fifth digit, you got 10 options again because you can repeat, right? And then last but not least, over here, you also can repeat the last one. So all in all, you will have the total number of 5 character codes would be 26 times 25 times 10 to the power of 3. Or you can just write 10 times 10 times 10. And all in all, this will give you 650,000 as the final answer to this question over here. Okay, so this is basically the 4 practice questions that we have before we move on to the next concept. Let me know if this practice was helpful for you, and if you got any questions, just leave in the comments below. If not, I will see you in the next video where we will go through in specific the formulas and the concepts needed for this entire chapter of permutation and combination. I'll see you in the next video.